No. Why is it this class? Quadrilateral. Okay?
Because it will make you tired.
No, you don't. I love this class.
Sometimes you're already tired.
Sometimes I am, but I've had 4 days of sleeping, so.
4 days?
Yeah. Friday, Saturday, Sunday, Monday. I slept for 4 days, so I should feel better. Okay, so the next one says if I have one pair of parallel lines, so same slope, right? And one pair of congruent sides. So one pair is parallel and one pair is congruent. I have what's called an isosceles. I'm definitely spelling this one wrong. Isosceles, and I think that's right. Isosceles trapezoid. Trapezoid. Who knows what that looks like? What's an isosceles trapezoid look like? Yes! Good. It looks like this. So I have one side that's parallel, right? That looks like this. And then one side that's congruent that looks like that. So those two are congruent. And then these two are parallel. Kind of looks like a pyramid with the top chopped off. Yeah?
No.
No? Okay, whatever. I tried. Okay.
Looks like a mountain top.
Except the sides are with the top chopped off?
Yeah.
Okay. We can say mountain with the top chopped off.
Yeah.
Top chopped off. Wow. Okay. So we have opposite sides are parallel and congruent. So the opposite sides are parallel and they're congruent. They're both parallel and congruent. But I have no right angles. Okay? No right angles at all. That is called, anybody know what that's called? Anybody want to guess? No? It's called a parallelogram. Parallelogram.
Yeah.
And it kind of looks like that. I'm going to attempt to draw it, so don't laugh too much. Right? So,
I'm laughing already.
it looks like this.
It's the ones down here. The crickets.
It's a bent over rectangle, right? It's a rectangle that's slanted. Oh, I should do these two. There we go. There we go. Yeah, it's probably at the bottom of the page.
Yeah, they're all at the bottom of the page.
Okay. Except for the isosceles trapezoid, yes. ABT. Okay, next, opposite sides are parallel and congruent, and all sides are right triangles. What is that? So they're opposite, they're parallel, and they're congruent, and they have right angles. What does that mean? Yeah, top drawer. Top drawer.
Yes, it's square.
It's not a square. It's a what?
Rectangle.
Rectangle. It says opposite sides are congruent, so it doesn't say all sides are congruent. That's a square, right?
Yeah.
Opposite sides are congruent. So rectangle. Whew. They look like they're congruent, right?
No.
Okay, all sides are congruent, but no right angles. Ooh, what's that called? Rhombus. Yes.
I forgot what a rhombus is.
Rhombus. So it's a square that's tilted on its,
This one?
it's squished, it's on its side like this. So I'm going to attempt to draw it.
That's where we learned these, but I forgot about them.
I guess that kind of looks like it. Don't laugh because just pretend they're all equal. Okay. And then we have all sides congruent, all right angles is a
What's the
square.
last one? Oh yeah, square.
And they're all the same side. Okay? So, yeah. I'm going to write a little bit more on this side.
Oh, what will we write last?
No, more than what I have written down here. Yes.
Still last.
Isosceles trapezoid. Isosceles trapezoid. Hi, Annie, what's your name? Araceli Andrade? Andrade, thank you. And that's what we're doing right there.
Wait, there.
Both of them, both papers.
Oh.
All right, BT, let me know when you're done.
Oh, I just noticed.
Oh, is this your phone being charged?
Oh, yeah, this one.
Okay.
You can leave it, please.
No, that's fine.
Well, you know,
Just sit on another chair.
Go ahead. Now, the chair.
Okay. All right, are you good, BT? Awesome. Okay, first page. So opposite sides are parallel. Which ones of these say opposite sides are parallel? So this only says one pair of opposite sides are parallel. So we have two sides. So opposite sides are parallel. Opposite sides are parallel. All sides, doesn't say anything about being parallel. I prematurely highlighted that. All sides, nothing about parallel. So it means this is either a parallelogram or a rectangle, right? Yes. Oh my Lanta, yes. Okay, so what's the difference between a parallelogram and a rectangle? Right angles. Okay, so if the angles are right angles, it's a rectangle. If they're not right angles, it's a parallelogram. Does that make sense? How do I tell if it's a right angle? Yes, but how do you know that they're right angles? If their slopes are not the same. Yeah, and what perpendicular, right? So what do their slopes have to be? Negative reciprocals of each other. So if I go back, we're going to go to the next page. And we're just going to go over the formulas again. Coordinate formulas can help us determine whether quadrilateral have certain properties. Let's revisit each coordinate formula and what each can help us do. So I'm going to use the Pythagorean theorem to find the distance. What's the Pythagorean theorem say?
A squared, B squared plus 3 equals C squared.
A squared plus B squared equals C squared, right? Okay. And that helps us find the length. Find the length of a side. Okay, helps us find the length of a side. And what that will help us do, it'll help us tell if the sides are congruent, right? To help tell if the sides are congruent. And congruent means equal. So if they're the same length, they're equal, right? Is everyone okay with that? Okay. Please make sure you're asking questions. While you guys are doing that, I'm just going to color in my little thingy here. Because I can, while you guys are writing. Is everyone done? Anybody still need time? Oh, people still have their pencils going. Oh, it looks so cute. Okay. Okay, so slope. How do I find slope? Who remembers? So what does slope equal? No, that y equals mx plus b, right? That's slope-intercept form. But how do I find slope?
Find x.
Slope equals the change in,
Y over
right? Change in y over the change in x, right? So what does change mean I'm going to do? What does the word change mean in math? What? Subtract. So subtract the y's and I subtract the y's. They don't give me enough room to write in here. Over subtract the, oh, there should be another t in there, x's. Okay, so I'm going to subtract the y's, right? Remember how we find the distance between the x's and the distance between the y's, right? We're going to subtract them. And then I see if the slope is positive or negative. It's pretty easy in, or I'm going to count spaces, right? Or count, oh, that's not count. Count, wow, I'm spelling so good today. Count, rise over, run. I'm in a coordinate plane. Can I not count squares? I can count rise over run. Do you need me to make that bigger for you guys? Is that better? I can count rise over run, right? Since I'm in a coordinate plane, as long as I'm in a coordinate plane, can I not just count squares? That's the easiest way to do it, right? Count squares. Okay. Is that better, Lay? I made it bigger for you? Awesome. Okay. So that helps us. So what does my slope help us do? Tell if the lines are parallel. Parallel. Well, how do we know if they're parallel? If lines are parallel, they have what? Same slope. Good. Same slope. Or perpendicular. How do we know if they're perpendicular?
The switch with negative.
They switch with the negative, so they're the opposite. Both the opposite what? What's the switch thing mean? What's that word? Reciprocal. Reciprocal. Do you want me to put an example down of opposite reciprocal? So opposite reciprocal would be like 2/3 and -3/2, right? One's negative, one's positive, and then the fraction's flipped. Or 2/1, -2/1, and 1/2. What else here? Okay, questions? Do I need to zoom in a little bit more? Yeah? Is that better? Okay. And if you look right down at the bottom, in the remember section down here, determine segments are parallel or perpendicular. Guess what it just says? I find their slopes. Says it just kind of repeats it. If the slopes are equal, the segments are parallel. If the slopes are opposite reciprocals, then they're perpendicular. So it just kind of restates what we just wrote. Okay? So that's a very important thing to remember. No, thank you. Okay. Any questions so far? Are we doing okay? This is just all remembering things, right? Except for our definitions of our quadrilaterals. So you guys are going to need that for today and tomorrow. Just telling you right now, okay? Okay. What am I going to do to find the angles? Oops. I know, I'm just telling you. What am I going to do to find the angles? What does perpendicular mean? What's the word perpendicular mean? Not what tells that they're perpendicular, but what does the word actually mean? What does it actually mean? Perpendicular, let's, can I come over here and write it? So, we did actually write this down, by the way. Perpendicular, yes, we did. Perpendicular means two lines that form 90-degree angles. That's what perpendicular actually means. How do I show that they're perpendicular? If their slopes are what? Negative reciprocals of each other, right? That's how I prove that they're... Oh, sorry, I can't turn that to the side. I'm trying to turn it on my iPad. It's not working. Two lines that form 90-degree angles. Hey, Alexa. Okay, does that make sense? So I know I need to show, if I want to show that they form a right angle, I need to show that their slopes are negative reciprocals of each other, right? That's how I prove it mathematically. Does that make sense now? Because I know if they're perpendicular that they form a 90-degree angle. That's the definition of perpendicular. So now I need to show that they're, if I'm trying to tell if they're parallel, what do I need to find? The same slope. So I want to find the slope of each line. Okay? Back to that page. So here we go. So in square, so we're going to use this little picture here for these next three little things it says. So it says in square A. Yeah. In square A, here's my square A. I'm going to be nice and color it in inside the line. In square A, show that all the sides are congruent and all the angles are right angles. So how do I show that the sides are congruent? I find the distance or how long they are, right? So how do I find out how long these sides are? Count. Yeah, they're just horizontal and vertical, so I can just count, right? So can I label these like side A, little B, little C, and little D? So how long is side AB? How long is side AB? That's this side up here. 4. Great. How long is side BC? 4. Beautiful. How long is side CD? 4. Great. And how long is side DA? 4. So what does that tell me? All sides are congruent. And I'm not going to spell out the word congruent. Guess what congruent? That little symbol means congruent. Yep, top drawer. Okay, all sides are congruent. That's what the congruent, I'm going to come up here. Congruent. I can use this little symbol. It's an equal sign with a similar sign on top, so I don't have to spell out congruent every time. I can just use that little symbol, and that means congruent. Okay, so if you see that little sign right here, this sign right here, oh, I did not mean to erase that. This sign right here, that means congruent, okay? So you know there's little shorthand tricks in math, right? So that means congruent. So then it says, all angles are right angles. How do I show, so I've showed sides. This is my side one. How do I show angles are right angles? Yeah, how do I do that? How do I prove? I have to prove it. I can't just say, oh, they look like right angles. How do I prove it mathematically? How? What am I going to do to find the angles?
You can measure it.
Form. So we're going to talk about angles now. So let's find the slope, right? M means slope of the line AB. And I'm just put a little AB down there. So what's the slope of this line? Right here. What's the slope of that line? So is it horizontal or vertical? I highlighted it. What's the slope of that line?
Vertical.
That's the highlighted one's vertical?
Is it horizontal?
Great, it's horizontal. Horizontal's laying down, vertical standing up. So it's horizontal. What's the slope of a horizontal line?
0.
0. Awesome. You guys know. Oh, it's highlighted. Let me go back to a pen. 0. Awesome. So what's the slope of BC? What type of line is BC? This one right here. What type of line is that? Undefined. That's beautiful because it's a vertical line and vertical lines are undefined. Gorgeous. What's the slope of my line, little line CD? 0. Beautiful. And what's the slope of DA? Undefined. Can I stop and talk about my notation really quick? Everyone, you guys all know that M means slope, right? And the little letters are subscript. What's a subscript? The letters written underneath, right? So notice I dropped them down below and wrote them smaller. So they're smaller. So this is the slope of this line segment. Does that make sense?
Yes.
The slope of this line segment. I don't want to write them on the same line because then that's MA. Okay? So it's a little subscript. Okay? Okay. So what do we know about lines that have a 0 and an undefined slope? What do we know about those ones? Of course, they're not negative reciprocals of each other. I'm sorry. Remember what we talked about that? I have one that's 0, one that's undefined. What do we know about those? They form a right angle. Those are the only ones that are opposite reciprocals of each other. Why are you looking around?
You're looking at me.
Because you said you knew nothing about them.
I didn't even hear what you said.
She was praying.
I didn't.
So we know if I have a line that's 0, slope of 0, and one that's undefined, they form a right angle. Okay? So these two form a right angle. And these two form a right angle. And these two form a RIGHT right angle. And these two form a right angle. How many right angles is that?
2.
1, 2, 3. How many right angles is that?
That's 3. It should be 4 though.
1, 2, 3, 4.
Yes, that's 4.
4 right angles. So does it form a square?
No. Yes.
Yeah, it forms a square. Okay. So did we prove it formed a square?
No.
Yeah, we did. We showed that all the sides are congruent and all the angles, by the way, which I'll do from now on, are 90 degrees. So yes, we showed what they asked us to show. Come on. No? Yes. 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 Don't shake your head no. Why is he so difficult?
I'm so tired.
Okay.
Yes. What?
What's the second part say? In rectangle B. So now we're going to a rectangle and we're going to rectangle B. Whew. Lovely. Let me highlight it for you guys. Okay, we're going to talk about rectangle B. Show that opposite sides are parallel. How do I show that sides are parallel? What do we find? I hate the lunch bell.
So loud.
I don't know why it's so loud. That can't be right.
But it is.
We end at 121.
Yes.
Wow, we still have a long time left to go. Unless my clock is wrong.
What time is
Oh,
it?
no, we do.
Oh, great, we have lots of time.
What time is it?
That's too much time.
12:31,
With the process?
12:20, 1:21. Okay, so in rectangle B, show that they're parallel. So how do I show that? I'm going to blow them in here. So I want to show that they're parallel. So in order to do that, I'm going to label them again, A, B, C, D. Are you guys okay with that? So I'm going to label them A, B, C, and D, just so we know which sides we're talking about. Does that make sense? So I need to show that sides are parallel. So which sides needs to be parallel?
Both of them.
Yeah, but which sides? A and D, and what side needs to be parallel to AD?
That's D, E, C.
B, C, great. And then I need to show that AB is parallel to what line? CD, okay? So I need to show those lines, right? And how do I show it? I need to find the slope of each of those lines. And I'm on a coordinate plane, so how do I find slope if I'm on a coordinate plane? Rise over, right? Slope, can you see that? Oh, no. Slope equals rise over run, yeah? So I'm going to make a triangle. I'm going to do the first set first, right? And I'm going to make a triangle. And then you should have passed math last year, so you could have been in advanced math again this year.
Math isn't fun.
Okay, so I'm going to find the slope of AD. I want to keep it blowed up so you guys can see, so I'm going to write over here. Is that okay? So I'm going to move this up here. AD and BC, AB and CD. You guys can write this all in your little, underneath the question where it's at, but I'm going to write over to the side if that's okay with you guys. So the slope of AD equals what? What's my rise? 2. What's my run? Is it positive or negative slope? Negative. So what's 2 over 2? Negative 1. So what's the slope of BC? What's my rise? 2. What's my run? Is my slope positive or negative? From B to C, right? Look, we're going, who said positive? It's okay if you said it. Look, from B to C, I'm reading it from left to right. Am I going up or down? I'm going up or down?
Down.
Down. So my slope is negative. So what's my slope?
Negative 1.
-1. So these are parallel because they are the same. Okay, now I'm going to change colors because now I need to find the slope of AB. I should have written that smaller. They are so loud. Those are your friends.
She's looking at you, Mammy.
She knows.
I know. That's not so bad.
She was laughing. We're like, those are your friends, Vanity. Probably your relatives. What's my rise? Whew. 4. What's my run?
4.
What's my slope?
1.
1. Oh my gosh, this is great. Slope of CB. I need to draw one more rectangle, huh? A triangle. What's my rise? Oh, I didn't ask what my slope was. Was my slope positive or negative? Positive, thank you. What's my slope? 4. And what's my run? And is my slope positive or negative? Great, so that equals? So that means these guys are also parallel. Awesome. So we know that the opposite sides are parallel. So, oh wait, does everyone have that written down? I know I'm kind of spending a lot of time on it. I need to look at, that's an eraser. I need to look at this line. Ooh, that kind of doesn't show up. And this line. Right, so I need to look at this one and this one. So AB and BC. So AB here, BC here. Are those negative reciprocals of each other? Negative 1 and 1. Yes, good. And BC and is this one, BC, and this one opposite negative reciprocals of each other? Yeah, they're all negative reciprocals of each other. 1 and negative 1, negative reciprocal of each other. So this is a rectangle. What else did they ask us to find? And the diagonals bisect each other. We haven't talked about diagonals yet, so we're not going to. So we're not going to talk about the diagonals. But if we had to, this is what we'd do. We'd find the length of the diagonals by doing a squared plus b squared equals c squared. And then we'd have to see where they met and do it again and again and again. We'd have to do it like a lot of times. That's why we're not doing diagonals right now. Okay? Okay. So what's the last one say? In rhombus, C. Rhombus, C. So what do we know about a rhombus? Okay, so again, we can look at the sides, right? We need to find the length of the sides. All sides are congruent. Wow. I'm going to have to write over here again. All sides are congruent, right? Let's write it down here. All sides congruent. All sides congruent. So I'm going to find the length of all my sides. And no right angles? No R-I-G-H-T right angles. So that's what I've got to prove. And then we're not going to talk about the diagonals. Okay? Okay. Whew. So let's label these again. A, B, C, and D. Now we actually have to find the distance of some of these, because we have to talk about all the sides have to be the same length. So let's do our sides first. Okay, so let's do the sides of the easy ones first. Let's do BC. How long is BC? 1, 2, 3, 4. Nice. 5. Beautiful. And how long is AD? AD. 5. Why were those easy? Yeah, because they're this way, whatever way, the horizontal, so I could just count, right? So now I need to find AB. AB is diagonal, so how do I find the length of a diagonal side? Yeah, I love her little. We're going to make a triangle. We're going to make a right triangle, and we're going to do what? A squared plus B squared equals C squared. So how long is one of my sides?
4.
4. How long is the other side?
3.
3. And I'm going to do 4 squared plus, that's a squared,
16
plus 3 squared equals x squared, or whatever you want to call it. So 16 plus 9 equals x squared. 25 equals x squared. And then what do? Square root it. Great. So what's the square root of 25? 5. So x equals 5. Or AB equals 5. Okay. We have one more side to find. I know. And which is DC. So I'm going to make another triangle. How long's one of my sides? The tall side, the up and down side. 4. How long's the side to side side? 3. Oh no. 4 squared plus 3 squared. Oh, isn't that exactly the same thing as what we just got done doing?
Yep.
What does x equal? 5. So are all my sides the same? All the sides are the same. Beautiful. Okay. So now we need to show that the lines are not perpendicular, right? So they can't be right angles, yes? Okay. So I need to find the slope of my lines. So now I'm just almost done. What is the slope of AB? What's my rise? What's my run? 3. What's the slope of BC? BC is here. 0. Are those negative reciprocals of each other? No. Okay, what's the slope of CD? What's my rise? What's my run? My slope positive or negative? Positive, right? Okay. Are those negative 0 and 4/3 negative reciprocals of each other? No. And what's the slope of AD? AD is this one. What's that slope?
5, 0.
0. Slope, not distance. Okay. Are those negative reciprocals of each other? Do I have any negative reciprocals? Nope. So my angle's right? Nope. So I can come down here, and you guys can, hopefully you did your work down here and not on the side, right? So, yeah, did we show that it was a rhombus? Because we showed that all the sides are equal and there's no right angles. Don't worry, we're going to do more of this tomorrow. Okay? Okay. So now let's go to your next page. We're going to do a few of this together, and then you guys are going to finish it on your own. Take a picture, upload it. Yes? Yes. Okay, list the different types of quadrilaterals and draw a small example, not including a kite, because we didn't talk about kite. Go. Jonathan. Jonathan. What's my first type of quadrilateral? You don't know any type of quadrilateral? One of the 5 types. Come on, you can do it. That's not a quadrilateral. Vanity, can you name one?
Word, don't come to me.
Oh.
Do you know one now, John? Rhombus. What is a rhombus? R-H-O-M-B. What does a rhombus look like? Jonathan, what's a rhombus look like? It looks like a what?
Tilted square.
A tilted square. Yeah, a tilted square. Okay, you guys, I'm not really good at drawing, but we're going to try.
I want to go sleep.
Yeah, so do I.
I'm tired.
Life is rough. So, and how do I show, if I want to show all the sides are equal, I'll just draw a little line through there. So all my sides are equal. Okay, anybody else have another type of quadrilateral? What's another one? Rectangle. Rectangle. And what's a rectangle look like? Woo.
Square, long square.
A long square. 90 degrees, right? So opposite sides are parallel and congruent. So parallel is the little arrow and congruent is the little line. Oh, these are all parallel too, sorry. Parallel, 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 parallel. Sorry. Okay. What's another quadrilateral? Anybody? Parallelogram, yeah. Parallelogram. And what does that look like? It's a tilted rectangle, right? Basically. So whew. Okay, that was pretty close. So these sides are equal and parallel. These sides are congruent and parallel. Okay. What's another type of quadrilateral? Got two more. Square, yep. SQUARE, and it has, that's pretty good, right? All four sides are equal and opposite sides are parallel. So, and then what's my fifth type? An isosceles. Our definition that we used was isosceles trapezoid, right? Trapezoid. And this one's going to be really bad. So I have one side that's congruent and one side that's parallel. So this side is congruent and these two are parallel. Beautiful. Phew! Guys, that was horrible. Not really. Use the coordinate grid to create a square. Go. Doesn't matter what size of square you draw. Just draw a square. And then list the points, the vertices of your square. How many different squares can we draw? A bazillion, right? Draw a square. After you guys draw a square, I'm going to draw a square. List your coordinate points at the bottom. See right down here? There we go. Draw a square. Oh, that was mean of them. Let's see, where do I want to start my square at? Whew. List your points down here. Okay, there's my square. How's that? Huh? I drew a little teeny square. Some people I saw drew this square. I've even seen it from here. Is this a square? Yeah, that's a square. That works, right? I think, I don't know where she put it, but she drew this square here. Some people drew this square here. As long as my sides are the same, right? Doesn't matter where I draw my square at? No, it doesn't, right? As long as all my sides are the same. Okay, so now draw a rectangle that is not a square. Draw a rectangle that is not a square. Which numbers do I want to use this time? I'm going to use let's see, 0.2, 3, 0.2, 0.4, 0.5, 0.3. There's my rectangle. Whew. Okay. Can you guys have a bazillion different rectangles? Yeah. You could have a rectangle going this way. Is that still a rectangle? Yeah. Okay. You guys can have lots of different rectangles. Is everyone okay with that? Okay, what do we want now? Oh. Ah! Okay, have fun with this one. Draw a parallelogram. Go. Parallelogram. Parallelogram. Where do I want to draw my parallelogram? Draw your own parallelogram. Don't copy mine. Oh, that's not gonna be a parallelogram. Wait, what?
The one over
Everybody has different numbers.
they look the same to me. The 1, 2, 3.
There we go.
Yeah, but
Yes, everyone has different numbers. So I've got a point at 1, 0, 0, 1. And I've got a point at 1, 4.5. Woo! And 2, 3.5. Whoa! Yes! Could I have done my parallelogram like this?
no.
Yep, I could have. That's a parallelogram. But I wanted to be different so people could copy me because I'm special. Okay, create a trapezoid. Woo! Trapezoid. Ah. Oh, that is so not going to work. Woo! So we've got 2, 0, and 2, 2, and 5, 3, and 3, 3. Woo! I think that should be one. I think that looks like an isosceles. Yeah, that looks like one. I could have drawn it this way though, right? I could have drawn 2, 3, 4 there, 5, and then gone into there and gone into there. And drawn one that looks like that, right? That's an isosceles trapezoid where my sides are equal. There we go. And draw a rhombus. Oh, I don't know if I can draw a rhombus. They cannot have right triangles, though. It's easy. It's easy.
It is. Let's see your rhombus.
I don't know if I can draw. Actually, I don't know if I can draw a rhombus.
Never mind.
Let me see your rhombus. Hold on. Let me see your rhombus.
Mine?
No, his. Does he have right triangle? Does he have right angles?
No.
I'm like, are you sure?
Your rhombus is different. Wait, you
She's
have to
dumb.
wait.
Let me see a rhombus. Yeah, but this side and this side are not the same length.
Yeah, they are.
No, they're not.
Yeah, they are.
No, they're not.
They're skipping 2. 1, 2, 1, 2, 1,
That
2,
this
1, 2.
this distance and this distance not the same.
It's 2.
Mathematically, it's not the same.
It's still a.
It is not a rhombus.
Yes, it is.
It so is not a rhombus.
What is it then?
It's not. Let me say it one more time. A rhombus.
Yes, it is.
It is not.
Yes,
It is not. Not a rhombus.
it is.
It's not a rhombus. I can't even do it with one. That doesn't work either. Just so you guys know, this distance and this distance, not the same. If I just did one here and one here, that's not the same distance. If I do 2 this way and then 2 this way, not the same distance. That is not the same distance. Just because I went across 2 squares, this distance is longer than this distance. That's why I'm like, I don't know if I can draw a rhombus that is equal. So let's see. If I do... But if I do this, this is going to be a square, so that's not really a rhombus. Yeah, go ahead. Because that forms a 90-degree angle, so that doesn't matter. No, yeah, I don't know if I can actually draw a rhombus on the coordinate plane and make it actually look correct. I could if my thing was bigger. If I had more than 5, I could draw it. If I had more space than 5, I could draw a rhombus, but I don't. I guess I could do this, and I start here. No, that's not going to work. But I can't get spots. That's almost a rhombus. But then I don't have coordinates, so that didn't really count. So that's a rough one. I'll figure that one out. Okay, here we go. The backside is yours to do. Okay, so you have 1, 2, 3, 4, 5, 6 problems for 20 minutes. It's less than 20 minutes. What?